Hello viewers, in today's session we are going to discuss an important and conceptual problem from definite integrals. And in this session we are going to discuss this problem where we are given a function f of x which is equal to x times maximum of x square and fractional part of x for all values of x belonging to the interval that is 0 comma 1, where 0 is included, right, and 1 is excluded. And we have to find out the value of this integral that is 1 by 3 to 1 by 2 and fx dx, right. So here the function f of x is given as the product of these two expressions, that is x, which is a polynomial function, and here we have maximum of x square comma fractional part of x. So we have to first modify this function f of x using the expression for maximum of two quantities, say a and b, right. So once we modify the function f of x, then we can easily find out the value of this definite integral, right. So let us start. So now consider two quantities a and b, right? And the maximum out of a and b is given by half, and we have here a plus b plus absolute value of a minus b, right? So whenever we have two quantities, say a and b, then the maximum of a and b is given by this expression, that is half a plus b plus mod of a minus b, right. So here the function f of x has maximum of x square comma a fractional part of x. So a maximum of x square comma a fractional part of x is given by this expression, right. So if we take a is equal to x square and b is equal to a fractional part of x, then the maximum of x square and fractional part of x is given by this expression, substituting the values of a and b. So here we have x square, then we have fractional part of x, and then we have mod of x square minus fractional part of x, right. Okay, now here we have a fractional part of x. So let us utilize the definition of fractional part of x by expressing it in terms of greatest integer function. So fractional part of x is x minus greatest integer of x, right. And here we can see that this function f of x is defined for all values of x belonging to the interval that is 0 comma 1. So we can also write here x is greater than or equal to 0 but less than 1, right. So see, when x lies between 0 and 1 including 0, then the value of greatest integer of x should be equal to 0, right. This is due to the definition of greatest integer function, right. See, if we take x is equal to, say, half, right, and half belongs to this interval, so half is 0.5. So the greatest integer of 0.5 is equal to 0, and similar is the case with say x is equal to 0, because here 0 is included, so greatest integer of 0 is equal to 0. And similarly, if we take, say, x is equal to 0.6, then the greatest integer of 0.6 is also equal to 0. So when x belongs to this interval, then the greatest integer of x should be equal to 0. So we can take a 0 over here. So the fractional part of x is now given by x minus 0, that is equal to x. So taking x as a fractional part of x, we have here half and x square plus x plus mod of x square minus x, right? Okay, now our next aim is to simplify this mod function, right? And it is given that x belongs to this interval, so let us make use of the definition of mod function to simplify this expression. Now the mod function is defined as a mod of p is positive p whenever p is greater than 0, and mod of p is 0 when p is equal to 0, and mod of p is equal to negative p when p is less than 0, right? So here we have that is mod of x square minus x, and we can write mod of x square minus x as mod of x times x minus 1, right? So let us concentrate on this term, that is x minus 1. Now see, x, it lies between 0 and 1, right? So whenever we have x lying between 0 and 1, then this expression x minus 1 is always going to be a negative quantity, right? See, whenever we have, say, x is equal to half, then x minus 1 is equal to half minus 1, that is minus half, so which is a negative quantity, right? So when x lies between 0 and 1 including 0, then x minus 1 is always going to be a negative for all x belonging to this interval, right? So this quantity, that is mod of x minus 1, is negative, and x is always a positive quantity, right? So the product x times x minus 1 is always going to be negative, right? So here we have mod of p is equal to negative p whenever p is less than 0. So now using this definition, we can define a mod of x square minus x as equal to a negative x square minus x whenever x square minus x is less than 0, right? Using this definition, because this number, that is x times x minus 1, which is x square minus x, is a negative quantity, and this is less than 0, right? So mod of x square minus x is equal to minus x square, multiplying these two quantities by negative 1, so we have here plus x, right? So now we have half and x square plus x, and here we have minus x square plus x. So x square and minus x square get cancelled, and we have half times x plus x is 2x. So 2 and 2 get cancelled, so we are left with x, right? So the maximum of x square and the fractional part of x is equal to x when x belongs to this interval, right? So now our function f of x can be modified as f of x is equal to x times maximum of x square comma a fractional part of x, and this quantity is equal to x. So here we have x, so we have x times x, that is x square. So using this expression, we have modified this function f of x as x times x, that is f of x is equal to x square for all x belonging to the interval 0 to 1, right? So now we can easily find out the value of this integral. So we have 1 by 3 to half, and f of x dx is equal to 1 over 3 to half, and here we have x square and dx. Now the integral of x square is simply x cube over 3, and here we have 1 by 3 to 1 by 2, right? So taking a 1 by 3 outside, then we have here simply x cube 1 by 3 to 1 over 2, and substituting the limits and taking the difference, we have 1 over 2 cube minus 1 over 3, and here we have cube, right? So the value of this integral is now equal to 1 over 3, and half cube is 1 over 8, and 1 over 3 cube is 1 over 27, and simplifying it, we have 27 minus 8 over 8 times 27, and we can now write here 19, and in the denominator we have 3 times 8 times 27, and this is 19 divided by 648, right? So viewers, the value of this integral is equal to 19 divided by 648. So this is how by using the concept of maximum of a comma b, we can easily modify functions of these kind, and we can further solve these type of integrals. Hello viewers, in today's session we are going to discuss another important and conceptual problem from definite integrals, and in this class we are going to evaluate this definite integral that is from minus 2 pi to 2 pi, and here we have a mod of 2 pi minus a mod of x and dx, right? So let us see how we can easily evaluate this definite integral by using two concepts. The first one is the definition of mod function, and the second one is the property of definite integrals, right? So let us start, and let us first call this integral as I, right? Now see here the limits of integration are from minus 2 pi to 2 pi, right? And the integrand is say the integrand is f of x, and it is mod of 2 pi minus mod of x, right? So here first of all we'll make use of an important property of definite integrals which connects the concept of even functions, right? So here we have minus a to a, and we have a function say f of x dx, and the value of this integral that is from minus a to a f of x dx is equal to 2 times the integral from 0 to a f of x dx, provided this integrand, that is this function f of x, is an even function, right? So a function is said to be an even function if f of minus x is equal to f of x, right? So if we replace x by minus x in this function f of x, and the function remains the same, then the value of this integral, that is minus a to a f of x dx, is equal to 2 times the integral from 0 to a f of x dx. So first of all we'll apply this property to this integral, right? So here if we replace x by minus x, then we have f of minus x, and here we have mod of 2 pi minus mod of minus x, and we know that a mod of minus x is equal to simply mod of x, right? And here we have mod of 2 pi minus mod of x, and which is simply the function f of x, right? So we can see that our integrand mod of 2 pi minus mod of x is an even function, right? So we can now write this integral I as 2 times the integral from 0 to a, and here the value of a is given by 2 pi. So we have 0 to 2 pi, and here we have simply a mod of 2 pi minus here we have mod x and dx. So now we have to evaluate this integral, right? And here we can see that we have a mod of 2 pi minus mod of x, right? So let us apply the definition of mod function. Now see, a mod of x is defined as positive x whenever x is greater than 0, mod of x is 0 when x is equal to 0, and mod of x is negative x when x is less than 0. And see, here the limits of integration are from 0 to 2 pi, right? So when x belongs to this interval, that is from 0 to 2 pi, then we have all the values of x as positive, right? So when x belongs to this interval, that is from 0 to 2 pi, then all the x are positive numbers, right? So mod of x must be equal to positive x because x is greater than 0. So here we can now replace mod of x by positive x. So we have 2 times 0 to 2 pi, and here we have mod of 2 pi minus mod of x is replaced by positive x. So we have mod of 2 pi minus x dx. So now we have to evaluate this integral 0 to 2 pi mod of 2 pi minus x dx. So let us again apply the definition of a mod function to mod of 2 pi minus x. Now see, x belongs to this interval, that is 0 to 2 pi, right? So whenever we take any value of x which belongs to this interval, then 2 pi minus x is always greater than 0, or in other words we can say that 2 pi minus x is a positive number for all values of x belonging to this interval. And when we take x is equal to 0, then we have 2 pi which is obviously greater than 0, and when x is equal to 2 pi, then we have 2 pi minus 2 pi, that is 0, right? And in that case 2 pi minus x is equal to 0. So we can now apply the definition of mod function. So mod of 2 pi minus x is equal to positive 2 pi minus x whenever 2 pi minus x is greater than 0, right? And mod of 2 pi minus x is equal to 0 when 2 pi minus x is equal to 0, and this is mod of 2 pi minus x is equal to negative of 2 pi minus x whenever 2 pi minus x is less than 0. So from this part of the definition, we can see that mod of 2 pi minus x is equal to positive 2 pi minus x when minus x is greater than minus 2 pi or x is less than 2 pi. Right? So whenever x is less than 2 pi, mod of 2 pi minus x is equal to positive 2 pi minus x, and our limits of integration vary from 0 to 2 pi, right? So now we can replace here this mod of 2 pi minus x as positive 2 pi minus x dx, and now we can easily find out the integral of 2 pi minus x. So we have here the integral of 2 pi dx as 2 pi x and x dx as x square over 2, and the limits of integration are from 0 to 2 pi. So now we can simply substitute the limits and we'll take the difference. So when we take x is equal to 2 pi, here we have 4 pi square, and then here we have 2 pi square, that is 4 pi square over 2, and when we take x is equal to 0, then both these terms reduces to 0, so we have 0 minus 0. So now simplifying this term, the value of this integral I is equal to 2 times, here we have 4 pi square, and here we have 2 pi square, right? And this is 2 times 2 pi square, that is equal to 4 pi square. So viewers, the value of this integral is equal to 4 pi square.